Good afternoon, everybody. I'm going to show you how to get GOMC and compile it on the Wayne State University grid computing environment. So here I am, I'm already logged into the grid, and I'm going to start by doing git clone. So let's see if it finds my stuff. Here we are. So we're just going to clone the Git repository. So we'll let that do its thing. All right, so now it has downloaded GOMC, and in order to compile this, we'll run metamake.sh. Okay, but before we can do that, we need to load the right compiler. So there are a number of compilers that are available on the grid, and the first thing we can do is issue the module spider command, and whoops, we can get an idea of what we have here. So if we issue module spider, it lists all of these different packages, so we have an idea of what's available to us. And all we need to do is do a module load to be able to compile our code. So let's take a look. And for example, we can do module load Intel 2019 to get the 2019 compiler and then build our code. That's the fastest option, so we're going to do that. If you want to run the code slower, and I'm not sure why you'd want to do that, but just in case, they also have the GNU compilers, and in that case, you probably want GNU 7, although really the way we work with this is we tend to run GNU 9 locally. Anyway, so let's give that a try. So we'll do module load, and then Intel / 2019. I hope this works. And yep, so it tells us right here I can't load both. I can't have both compilers, so we're going to do a module swap. So we're going to swap that for this. And that's what we've got. Okay, so now let's run metamake and see what happens. So it found the correct compiler. It's checking a bunch of different things to make sure the code is compilable. And it's going to do its thing. So something you might find if you try and compile code on the command line on the grid is that they shut you down. They don't want you to compile code on the interactive nodes. So what you have to do is you have to put together this nifty script. And these are basically the commands you've got here that you put in this script. And so you've got everything that starts with a hash and a S batch tells it this is a special command for the job scheduler. Okay. And so this these email things I think you can figure out. The time tells you how long you expect to have to run this thing. Q minus Q primary, this is the primary queue, which are supposedly the fastest computers. You have to specify some memory. You have to be careful here because if you don't, you can get stuck on a low memory machine and run out of memory when compiling. And then we've got these other things. This says minus N1. This says I want to run on one node. Number of tasks, I'm going to have one task, and the number of tasks per core is equal to 1. And then also, because we're going to use the Intel compiler, we'll include module load Intel / 2019, and then you go /metamake. All right, so that's our command file. And And so you would submit that by sbatch compile.sh, but I already have this running, and if I issue the QME command, I can see that my job is still running. It's doing something there. Okay, so we'll come back. This has been running for a while. We'll just take a quick look at it, see where it's at. So we're 77% done in terms of building GOMC. If we go to the bin directory, we see it's already created one of the executables. So if we were interested in running NPT simulations, we could do that. But we'll just wait, and we'll come back in a minute and see what's going on. So on the grid, for some reason, this thing compiles extremely slow. I'm not quite sure why. So it might take you 5 or 10 minutes to get this thing compiled. Okay, so it looks like our job has completed. If we look at the output file, so we'll just take a quick look at that. And you see that it's at 100%. We go to the bin directory and we see we've got 4 executables here, one for each ensemble. Now these are all CPU executables. If you want a GPU executable, you have to compile this on a node on the grid that has a GPU and has the CUDA libraries installed. So in this case, I didn't do that because I'm going to run on the CPU. But anyway, that's how you obtain and compile GOMC on the Wayne State University grid. Thank you and good luck.